Previously in Power Play.
Whoa, what's happening?
A master of products you have proven to be, but the master of quotients we have yet to see. Only the best can lift division's haze. Can you navigate the quotient maze?
Wait, I think we just unlocked a secret level within level 4. Oh, I'm so glad you're back. I've been stuck here at level 4 since our last lesson. We're going to have to learn the power of a quotient property to navigate our way out of the division maze and finish level 4. But first, if you haven't completed the discovery activity in your guided notes, pause the video here to do that now. Let's start by taking a look at this first column. Do you notice any similarities to the expressions we've simplified before? I notice that there's an expression inside parentheses and an exponent outside. That's similar to the expressions we simplified with the power of a power and the power of a product properties. But what's different about these expressions? With the power of a power property, the expressions had only one element inside the parentheses. With the power of a product property, the expressions had elements that were being multiplied inside the parentheses. But here, these elements are dividing. That must be why it's called the power of a quotient property. In this first row, the starting expression is m over n cubed. The expression has that outer exponent of 3, so it makes sense why the next column has m over n multiplied by itself 3 times. The third column says to rewrite the expression with one numerator and one denominator. Because each of these m over n's are being multiplied, and multiplication is commutative, we can combine all the m's into one numerator and all the n's into one denominator. This new version of the expression makes it a bit clearer that we have 3 m's multiplying, giving us m cubed in the final numerator, and 3 n's multiplying, giving us n cubed in the final denominator. If we consider the original expression, m over n cubed, multiplying m over n by itself 3 times should give us 3 m's and 3 n's, which is what this final expression says. What about this next row? Again, there's division, a cubed over b squared, all raised to the power of 2. What's different about this one? This time there are exponents inside the parentheses as well as outside. The next column of this second row looks a bit different too. The original expression had everything inside the parentheses squared, which means to multiply the base by itself. So we have a cubed over b squared times a cubed over b squared. Then it looks like this top part was expanded even further. Then, because multiplication is commutative, the third column shows all the a's combined into one numerator and all the b's combined into one denominator. If you are stuck before and still need to complete the discovery activity and the reflection question, pause the video and do that now. Do you think you've got an idea of how the power of a quotient property works? Feel free to pause the video here if you want to compare your answers with mine on the screen. The reflection question included with this activity asks for you to predict how you think the power of a quotient property works. So be sure you've recorded your thoughts before continuing. Ready to learn the power of a quotient property so we can navigate our way out of the quotient maze? Let's do it! The power of a quotient property states that the quotient of elements such as x to the power of a divided by y to the power of b raised to some exponent c can be simplified by distributing the outer exponent to the numerator and denominator of the expression. This looks like we may need some of our other properties to simplify the numerator and denominator from here. That must be why this property is still part of level 4. The properties build on each other. Now that we have the information we need, let's find our way out of that maze and beat level 4.
Ready? Here we go! Whoa, this is pretty cool.
Here's the first checkpoint. It appears we have to simplify this expression in the middle, and then the answer should show us which direction to choose to continue through the maze. We have u cubed over x squared, all raised to the power of 5. According to the power of a quotient property, when a quotient is raised to a power, we can distribute the outer exponent to the numerator and denominator of the expression. How should we rewrite this expression using the property? Distributing the outer exponent to the numerator gives us u cubed raised to the power of 5. After distributing the outer exponent to the denominator, we have x squared raised to the power of 5. Which property do you think we should use from here? In each of these chunks, there's one element inside the parentheses with an exponent being raised to another exponent. Since there's only one element inside each set of parentheses, we need to use the power of a power property, which tells us that we can multiply the exponents. Pause here to simplify the numerator and denominator of this expression using the power of a power property. U cubed to the power of 5 becomes u to the power of 3 times 5, or u to the power of 15. And x squared to the power of 5 becomes x to the power of 2 times 5, or x to the power of 10. Are we done? There's only one u element and one x element, so this expression is simplified as much as possible.
So, which direction should we go?
I guess it's gotta be down.
Yes, we did it.
Next checkpoint. We have e to the 6th f over g cubed, all raised to the power of 2. According to the power of a quotient property, when there's a quotient raised to a power, we can distribute the outer exponent to the numerator and denominator. Pause the video to do that now. After distributing the outer exponent of 2 to the numerator and denominator, we have e to the power of 6 f squared, all over g cubed squared. What should we do next? In the numerator, there's a product, e to the power of 6 times f, all squared. In the denominator, there's one element, g cubed squared. Here's a list of all the properties we've learned so far. Take your time to choose the correct properties to simplify both the numerator and denominator of the expression. Pause here, simplify this expression as much as possible, and we'll check your work when you're done. Because the numerator has a product raised to a power, we need to use the power of a product property, which tells us to distribute the outer exponent to each component within the parentheses, giving us e to the power of 6 squared times f squared. How can we simplify the numerator further? We can use the power of a power property. When an element with an exponent is raised to another exponent, the exponents can be multiplied, making this first component e to the power of 6 times 2, or e to the power of 12. Is there anything else to be done in the numerator? F squared is already simplified, so we're ready to move on to the denominator. In the denominator, we have g cubed squared, another single element with a power raised to another power, so according to the power of a power property, these exponents can be multiplied. G to the power of 3 times 2 becomes g to the power of 6. Is there anything else that can be simplified? Each component remaining has a different base, so this expression is fully simplified. Which one? Up! Yes! This has got to be the last checkpoint of the maze. We need to simplify 5a cubed b squared over bc, all raised to the power of 4. We've got a quotient, all raised to the power of 4. Remember, since we're simplifying, we need to follow the order of operations. That means everything inside the parentheses needs to be simplified before distributing that outer exponent of 4. Pause here, use whichever properties you need to simplify as much as possible, and we'll check your work when you're done. What did you notice inside the parentheses that needed to be simplified? There are 2 b components, so these need to be combined. This fraction bar means division, so we can use the quotient of powers property, which tells us that when elements of the same base are being divided, we can subtract their exponents. How do we know if the final b component will be in the numerator or the denominator? The b component in the numerator is larger, so the final b element will be in the numerator. This gives us 5a cubed b to the power of 2 minus 1, or just plain b, over c, all raised to the power of 4. Is there anything else inside the parentheses that needs to be simplified? Nope. So now we're ready to move to the next step in the order of operations, exponents. There's 2 exponents in this expression, but this a cubed inside the parentheses can't be simplified anymore. So we can address this outer exponent of 4 and, using the power of a quotient property, distribute it to both the numerator and the denominator. Now we need to simplify the numerator and denominator groupings. Starting with the numerator, what should we do next? There's a product raised to an exponent, and the power of a product property tells us to distribute the outer exponent to each element within the parentheses, giving us 5 to the power of 4, a cubed to the power of 4, and b to the power of 4. Can the numerator be simplified any further? 5 to the power of 4 needs to be evaluated, giving us 625. What about a cubed to the power of 4? A single element with a power raised to another power? You got it. The power of a power property. We can multiply these exponents, giving us a to the power of 12. Now all that's left in the numerator is b to the power of 4, which is already simplified. Is this numerator simplified now? Yes. What should we do with the denominator? C to the power of 4 is already simplified. And now that the numerator and denominator are simplified, we're done, right? It's generally a good idea to check each element to make sure. And I only see one element of each base, so it's simplified. Which way? Which way? Oh, left! Woo! Level 4 completed! We did it! We've already completed the discovery activity, and we're wrapping up the guided notes, so all that's left is the online practice. There's also another bonus activity in the PDF that you can work on if you want to keep practicing applying these properties. I don't know about you, but to me it seems like these levels keep getting more and more complicated. I think we might be getting close to the end of the game. And if that's the case, it's important that we master these properties because I have this funny feeling that at some point we'll get to apply them all. But until then, keep practicing so that you can harness the power of the power. See you next time.